So, in the last class, I was discussing polarization by reflection. So, what I have discussed with you that if you are having a p polarized light, you are having a plane polarized light like this. Suppose this is incident. This is the incident. P polarized light means electric vectors are like this. This is p polarized light. Okay? And it is incident on this interface. This is N1. This is N2. This refractive index of the first medium is N1, refractive index of second medium is N2. Then if this p polarized light is incident at polarization angle or Brewster angle, then here there will be no reflected light, only there will be transmitted one. So there will only be transmitted light. So here there will be no reflected light. So R will be 0 here. R will be 0 here. So this is for p polarized. What type of light is this? Here all the electric vectors, they are parallel to the plane of incidence. So this is p polarized light. So this is p polarized. P polarized light. Okay. Second is S polarized light. I was discussing if at the same angle S polarized light is incident at the same angle theta p. Angle is suppose same here. This is theta p, but this time you are having S polarized light. This is S polarized light. That is incident. S polarized. This is S polarized light. Then you will find out that in this case you will have both reflected light as well as transmitted light. So this is reflected light like this, and this will be transmitted light. So in case of S polarized light, you are going to have both reflected as well as transmitted. Here, this angle will also be theta p. Okay, this will be angle of refraction R, and this will be R. So I was discussing this. Now suppose, okay, suppose we are having unpolarized light that is incident at polarization angle. Now I want to combine these two. So what I'm saying, suppose unpolarized light is incident on an interface at the polarization angle theta p, then what will happen? So here now we are having unpolarized light, and this unpolarized light is incident at polarization angle here. So this angle is polarization angle. This is theta p. What type of light is this? This is unpolarized light. So unpolarized light, okay, electric vectors of the unpolarized light will be like this. Okay, it will have electric vectors in all possible directions like this. This is unpolarized light, that is incident. Now what I am going to do, all these electric vectors, they can be resolved into two mutually perpendicular components. One that will be parallel to the plane of incidence, another that will be perpendicular to the plane of incidence. So parallel component will be this one. These are the parallel components of electric vector, as well as perpendicular component. So what type of light is incident? That is unpolarized light. All the electric vectors of this unpolarized light, they can be resolved into two components, one parallel to the plane of incidence and another perpendicular to the plane of incidence. So when these two components, they are going to incident on this interface between two mediums having refractive index n1 and n2 at theta p at polarization angle theta p equal to tan inverse n2 upon n1. Then what will happen? In the reflected light, okay, in the reflected light only these dotted components which are perpendicular to the plane of incidence, they will be present. Angle is same. So try to understand ठीक है, in the reflected light, if you consider the reflection of these dots, then these dots will be present in the reflected light, and these dots, they will be present in the transmitted light. But if you look at these parallel electric field components, you know that if this type of light having electric vectors parallel to the plane of incidence, then if angle of incidence is theta p, then reflected part for these parallel components will be 0, and you are going to find out them here. They will only be transmitted. So these parallel components of electric vectors, they will be only transmitted. There will be no reflected component of these electric vectors. While for these perpendicular components, they will be present in reflected light. They will be reflected back in the same medium as well as they will be transmitted. So what you are going to have here, you will have this type of light in the transmitted one, and this type of light in in the reflected one. So if you look here, for this reflected light, then all these electric vectors, they are like this. They are confined in this plane, and this will be a plane polarized light. And what type of light will be? This will be S polarized light. S polarized light. So what you are observing here, if unpolarized light is incident on an interface at polarization angle, then in the reflected light only perpendicular components, perpendicular electric field components will be there, and this light will be plane polarized light. Reflected light will be plane polarized light, having all the electric vectors confined in this plane, and this is S polarized. And here this transmitted light, if you look at electric field components, then this here in the transmitted light, in the refracted light that is entering into the second medium, basically these parallel components, they will be more. Their, their number will be more as compared to dotted component. These dotted component, they will be reflected back also. So here, this will be partially polarized light. What this will be? This will be partially polarized light. Polarized light. So in this way, you can produce plane polarized light from the unpolarized light with the help of reflection. So with the help of reflection, okay, one can produce plane polarized light, S polarized light here from the unpolarized light. So this is the first method of producing plane polarized light. Is it clear to everyone?
Sir, in which
Hello.
plane you told that dot line is there, means in which plane you have shown with hand? Please show it once.
Electric vectors, they will be here in this. This plane will be perpendicular to this board,
Okay, sir.
and it will have this line. This is line of propagation. So a plane passing through this line of propagation and perpendicular to the board. Okay, that will be the
Okay.
plane of vibration for this reflected light. All the electric vectors, they will be confined in this plane that is perpendicular to the board and passing through this line of propagation. Is it okay? Hello. Is it
Yes.
clear, beta? So this is the first method. In the last class, there was a question. Okay? There was a question that during polarization, we are just considering electric field. What is the reason for this? Okay? So try to understand when we are dealing with polarization, what is happening here. Okay? That if you are having a polarizer, I will come to this. I have not discussed this, but I just want to answer that question. So if you are having this polarizer, okay, an unpolarized light is falling on it. This is the electric vector, okay, of unpolarized light. When this unpolarized light is incident on it, then this polarizer will allow electric vectors, only electric vectors which are parallel about a particular axis. There will be a particular direction in this polarizer And if electric vectors are parallel to this direction, they will be passed. All the electric vectors, they are parallel to this pass axis. They are going to pass through this polarizer. Other electric components, they will be absorbed by this polarizer or they will be reflected back. So what you are going to have here on the other side, you are having plane polarized light. So here you are having plane polarized light. Okay, try to understand. So what is happening here? Here this light is interacting with this material. So during this polarization process, what is happening? Light is interacting with the material. Light is interacting with the material, with the matter or material, with the material. Now, ठीक है, in this material there will be electrons, and electric field and magnetic field, they are going to interact with these electrons of this material. So here I am considering electrons only, ions will also be there. Suppose light is incident over it, so electric field is present as well as magnetic field is present with this incident light. So that electric field as well as magnetic field, that is going to interact with this material, or you can say they are going to, these fields, they are going to interact with the electrons. So how much electric force will be there? How much electric force is going to act on the electron due to the electric field? That will be E into E. E into E. I'm talking about magnitude here. Okay? That will be this much. This is the magnitude of the electric force that is acting on the electron due to the electric field of this light. How much magnetic force is going to act on it? That will be QV cross B. So this will be EVB beta. This will be EVB. This will be EVB. Now if you divide these two, then you are going to get FE upon FM. This is the simplest way. If someone asks you in some interview, then this is the simplest way in which you can explain why you are not considering magnetic field during polarization. So Fe upon Fm, so this will be E will cancel out, and this will be E upon V into B. And you know that this E by B, this will be C, or this will be C by V. ठीक है ना? What is V? V is the velocity of the electron here. So what will be V? V will be the velocity of the electron, and here C, or it may be C by N. So that is the velocity of the light. And you know that C is much, much greater than V. C is much, much greater than V. It will be like this. So here, what can you observe that this Fe is much, much greater than this Fm. So when light is interacting with the material, so a pressure is exerted by this electric field, a force is exerted by this electric field on this material, and that will be much, much greater as compared to this magnetic force. This is negligible. This magnetic force is negligible as compared to this Fe, electric force. So that's why here this part is going to dominate, and this will be negligible as compared to this. So that's why when light is interacting with a material, okay, during polarization, how that polarization will be possible? Because other electric vectors, they will be blocked by this material, and a part of the electric field that that is parallel to this axis, that will be passed. So why this is happening? This is happening due to the interaction of this light with this material. So this interaction is taking place, and in this interaction this electric field is playing much more, okay, much greater part as compared to this force is, magnetic force is negligible. That's why during the interaction of this light through this material, and as a result of which polarization is taking place, that is dominated by this electric vector. And we consider only electric vector during the study of the polarization. This magnetic force is very, very weak as compared to this electric force. So this is the reason why you deal only with electric vectors during polarization here. However, remember this when in the last class I also told you if very huge, if very large intensity light is interacting with the material or with the plasma or ionic medium, then this B field also plays very important role. It also becomes important. ठीक है, and a different type of force, non-linear force, that is known as ponderomotive force, that comes into the picture, and it becomes important. Magnetic field starts becoming important. But here, the intensity with which we are working here, in that case, this Fe, it is much greater as compared to Fm. At very high intensity, actually, what happens at very high intensity? Velocity of the electron, it will become large. It will start becoming relativistic. It will start approaching towards C. So that's why this part will also becoming important, but only when intensity is very high. Here, this is much greater. This is negligible. So you are going to deal only with electric vectors. So this is a answer of that question, that why we are dealing only with electric fields during this process of polarization. So now,
Thank you, sir.
welcome. So now, come back to this. So basically here, with the help of this, one can very easily produce the plane polarized light from the unpolarized one. Next is Malus law. Beta. Next is Malus law or polarizer. ठीक है? Next is
Sir,
polarizer.
sir.
Yes, beta.
So naturally, we can't get any plain polarized light. So, all the light that is coming from the atmosphere, that is unpolarized light. Only we can produce the polarized light by
Yes.
using this technique, right?
Yes, beta.
Okay.
So next is production of plane polarized light. Production of plane polarized light from, yeah, bipolarizer. You can write. Oh, sorry. Where I was. Just so production of plane polarized light by polarizer. Polarizer. ठीक है? So first, what is polarizer? Actually, we are not going into deep into the structure of this polarizer. So here, polarization is an optical device, you can say, ठीक है ना, which allows to pass electric vectors of the incident light, ठीक है, only in a particular direction. So electric vectors which are parallel, suppose this is the pass axis of this polarizer, what we call, this is known as pass axis. Pass axis. So this polarizer works in such a way that when the light is incident on it, then electric components which are parallel to this pass axis, they will pass through it, and all other components which are going to fall on this, ठीक है ना, they will be reflected back or they will be absorbed. So what we are going to get on the other side, on this side, we are going to get plane polarized light. Plane polarized light. Here, an unpolarized light is incident. So from here, we are going to have plane polarized light whose electric vectors will be parallel to the path axis. So whatever plane polarized light will emerge, ठीक है, from it, ठीक है ना, it will have electric vectors parallel to the path axis. So from here, unpolarized light is incident. Unpolarized light is incident. So many electric vectors were there. ठीक है, in every direction electric vectors are there, but out of these only those which are parallel to this, try to understand, only those electric vectors which are parallel to this, they will be allowed to pass. Other will be reflected back or absorbed. So this type of optical device is this. This is known as polarizer. This is polarizer. I'm assuming, suppose for your understanding, I'm saying this axis is suppose Z axis, you can say. Light is suppose propagating in the Z direction, and this polarizer, it is in XY plane. This polarizer is in XY plane, and it is light is propagating in the Z direction. So this polarizer, try to understand, it is in XY plane, XY plane. So how can I show this? I'm showing a polarizer here. Up- What is happening? Just 1 second. Beta. So this is polarizer. This is polarizer here. And I'm saying this is x-axis. Okay, this is x-axis. And this is y-axis. This is y-axis. You can choose y-axis as the path axis, or you can consider the x-axis as path axis. This is your choice. So I'm assuming, just for simplicity, I'm saying this is path axis. Path axis. Okay. So in different questions, I can choose path axis here or here. That is your choice. That will be mentioned on the polarizer. So there will be a particular direction in which electric vectors they are allowed to pass. Other vectors which are not parallel to this axis, they will not be allowed. So now a light is incident on it. This is XY plane. Light is incident like this. Light is falling on it like this. So light is falling on this. Light is propagating like this in this direction and falling like this. So electric vector of this light may be anywhere. It may be like this. It may be like this. It may be like this. So here, try to understand. This is incident light. This is incident light. So electric vector may be like this. Electric vector may be like this. Electric vector may be. So electric vector can have any direction. Can have any direction. I'm considering an arbitrary electric vector of the incident light in this direction. Suppose this is, ठीक है ना, this is the electric vector. I call it as E naught, or you say its amplitude is A. I'm saying this is the amplitude of the incident light electric field, A. Can you tell me what will be the intensity of this light? Intensity of the light that is incident with amplitude A, its intensity I naught, that will be A square. A square. What it is? This is the intensity of the incident light. Intensity of the incident light. Incident light. I not equal to A square. And suppose this electric vector is making an angle theta, with the path axis. Now, the component of this electric vector that is parallel to the path axis, that will be allowed to pass. An electric vector that is perpendicular to this, that will be absorbed or reflected back. So you can resolve this into two components. One component is this will be A cos theta. A cos theta is allowed to pass. ठीक है, A cos theta is allowed to pass through this polarizer. And this one, this is A sin theta. It will be absorbed or it will be reflected back. So we are concerned about this A cos theta. So try to understand, light is incident like this. So just 1 second, I will show you. So here, this is the incident light. I'm saying this is the direction of incident light. Light is incident on it like this, and light is transmitted. ठीक है ना? ये ठीक से बन नहीं रहा के भाई. It will be. Light is like this. So try to understand. Here you are going to have electric vectors which are parallel to this axis. ठीक है. What will be the electric vector here? ठीक है. Whatever electric vector here is, that is what will the amplitude of this? That will have a cos theta. A cos theta. So what will be the here intensity of the transmitted light? Here this was the incident light of intensity I naught, and this will be IT, emerging light. ठीक है ना, transmitted light. What will be its intensity? That will be a cos theta. A cos theta square of this. So that will be a square cos square theta. What is a square? A square is I naught. So IT, that will be equal to I naught, incident light intensity, cos square theta. This will be the intensity of the transmitted light. Try to understand, this is the intensity of transmitted light. Is it clear? So if an unpolarized light, so what you are saying this is a polarizer, so don't confuse. ठीक है ना, this is a polarizer, you call it as P, polarizer. And a polarized light is incident on it. Plain polarized light like this. This is a plain polarized light. ठीक है? Like this. Its intensity is I naught. I naught. And angle between this electric vector and its path axis, that is theta. So what is theta here? Theta is the angle between the electric vector and the path axis. You can write here theta is the angle between the electric vectors of plane polarized light. Theta is the angle between the electric vector of plane polarized light and the path axis of polarizer. What you are going to get here? Here you will have plane polarized light. This will also be plane polarized light. This was plane polarized light. This is plane polarized light. Passing through this polarizer, then its intensity will be changed. Its intensity here, that will be I. I will be equal to I naught cos square theta. And this is known as Malus law. What is this called? This is known as Malus law. Malus law. This is Malus law. Is it clear up to this point, beta?
Sir, can you repeat theta once again? What is theta?
Please. Theta is the angle between. Theta is the angle between the electric vector of incident plane polarized light. Theta is the angle between the electric vector of incident plane polarized light and the path axis of the polarizer. So try to understand, this Malus law is applicable for incident plane polarized light. Remember this. So you can write here Malus law is applicable. This is applicable for incident plane polarized light. ठीक है? For incident plane polarized light. Now, another important aspect of this is, suppose I start rotating this. ठीक है? Try to understand, I start rotating it. So this diagram is actually not looking so good. Just now it's okay. And this is IT. Now, what I'm doing, I'm rotating this polarizer. I start rotating this polarizer. So I'm rotating this polarizer about this axis. This is the axis of rotation. Okay, what you are doing, you are rotating this polarizer now. When you are rotating this polarizer, then try to understand this path axis is going to rotate. And the angle, theta angle, that is going to change. Suppose you are rotating this polarizer with an angular velocity omega, then theta at any time, okay? Try to understand theta at any time, that will be omega t, okay? I'm assuming this is theta equal to omega t. Omega t. So initially at time t equal to 0, I am assuming theta is 0. Okay, initially at time t equal to 0, for simplicity, I am saying this electric vector is like this and then it is rotating. So theta at any time will be omega t. Remember this. So what we are doing, we are rotating it. We are rotating it. Then what will happen? When theta is 0, here, I want to show you when theta is 0. Theta is 0. When electric vector at theta equal to 0, this A will be parallel to this x-axis, path axis. Okay? Where will be this? This electric vector will be parallel to the path axis. So this complete electric vector that is going to pass. What will be on the other side? Theta is 0, so cos 0 will be 1. And on the other side, electric vector amplitude will be A. So what will be the intensity? You are going to have intensity on the other side as A square, or you will have I naught, maximum intensity on the other side. What you are going to have on the other side, this will be the maximum intensity here, I naught. I naught. Okay? Now, when theta becomes 90 degree, when theta becomes 90 degree, means path axis is here and this electric vector is here, or you can say path axis is becoming perpendicular to this electric vector. Okay? In that case, then this will be cos 90 is 0 and intensity is going to be 0. Intensity will be 0. Okay? Next, when theta becomes 180 degree again, 180 degree. When theta becomes 180 degree, then what will happen? Again, electric vector will become parallel to this path axis. Okay? When angle theta is 180, means you are saying that electric vector is like this. Then automatically that electric vector is going to pass. So what will be the intensity? Intensity will be again A square or I naught. So this is again maximum intensity. When you are having theta equal to 270, then path axis and electric vector, they are perpendicular to each other again, and intensity will become 0. So in one complete rotation, in one complete rotation, you can observe that in one complete rotation from 0 to 360, at 0 and 180, intensity will become maximum. 2 times it is becoming maximum in one complete rotation, and 2 times it will become 0. So intensity is going to be 0 at theta equal to 90 degree and theta equal to 270 degree. So in one complete rotation, 2 times intensity is becoming maximum and 2 times intensity is becoming minimum. So what can you conclude here? You can conclude that if a plane polarized light is incident on a rotating polarizer, if a plane polarized light is incident on a rotating polarizer, then on the emerging side, intensity will become 2 times maximum. You will get 2 maximum intensity positions and 2 minimum 0 intensity positions. But when incident light is plane polarized light. So you can check either the given light is plane polarized or not with the help of this test. This may be a test to check either the given light is plane polarized or not. So please write here, if a plane polarized light is incident, if a plane polarized light is incident on a, if a plane polarized light is incident on a rotating polarizer, is incident on a rotating polarizer, if a plane polarized light is incident on a rotating polarizer, on a rotating polarizer, then Then on the emergent side, intensity of the light will become maximum 2 times. Intensity of the light becomes maximum 2 times, sorry, becomes maximum 2 times, and 0 2 times, and 0 2 times. So this is a test for plane polarized light. If you want to check either a given light is plane polarized or not, so just pass that light, unknown light. Okay? So what I'm saying here, if you are having unknown light, okay? Here you are having a rotating nicole. Here I am having a rotating nicole. This is a rotating nicole. Okay? It is, this is the way light is passing through it here. This is unknown light. Here I am having unknown light. Unknown light. Okay? And this is a rotating nicole. It is rotating like this. And what I am getting here, two maximum intensity positions. Two maximum intensity. And two zero intensity positions. Zero intensity. If you are getting this result, this is indicating that unknown light is plane polarized light. Is plane polarized light. This will be. Okay, unknown light is plane polarized light. This is one of the result. Next
So,
is suppose, yes, beta, please.
sir, on the angle 0, 90 degree, 180 degree, 270 degree, we get to maximum and two zero values.
Yes, beta. And
But
at
between
other angles,
angles,
at other
at
angles, intensity will be in between 0 and maximum. I will show you. I'm coming to that. Okay. So for the rotating nicole, if you plot intensity for a rotating, not nicole, sorry, for a rotating polarizer, if you plot intensity, okay, this is intensity as a function of theta. Here you are having intensity. So for this, this is 0 angle. I say this is pi by 2. Here this will be pi, 3 pi by 2, 3 pi by 2. And here you are having 2 pi, 2 pi. And I'm saying I naught is somewhere here. So I'm saying this line is representing the maximum intensity. This is I naught. Okay? This is the intensity of the incident plane polarized light. This is the, in just 1 second, beta. So this will be. Am I audible, beta?
Yes, sir.
Hello?
Yes, sir.
Okay. Now, at 0, what was the intensity? Intensity was here. And what is the formula of intensity of the emergent light? Formula is I equal to I naught cos square theta. You are going to plot it as a function of theta. So you are plotting actually cos square theta. So here it is maximum. At pi by 2 it is 0, and again here you are. So you are going to have, this is a, this type of plot you are going to have. Something like this. This type of uh, this type of pattern, this type of plot, you are roughly this type of plot we are going to get. This type. So here. So at 0 and pi and 2 pi, it will have maximum intensity. At pi by 2, 3 pi by 2, it is going to, this will also be like this. So a little bit, this is a plot of cos square theta. थोड़ा ठीक से बना नहीं है, but this type of plot will be there. ठीक है? This type of plot. Is it clear what I am saying?
Yes.
So at other points, at other angles, you will find out in between intensities will be there. Next is here, what I'm saying that if a plane polarized light is incident with intensity I naught, then on the transmitted side, transmitted light, it will have an intensity I naught cos square theta. But suppose incident light, what is happening if incident light is unpolarized? So this is my polarizer, and I'm saying its path axis is this. This is x-axis, this is path axis. I'm saying this is path axis. Path axis. So this is another one. This is perpendicular axis, y-axis, I say. So now unpolarized light is incident on it. Okay? Unpolarized light is incident on it. Just 1 second. So unpolarized light, this is y-axis here. So unpolarized light, this type of unpolarized light is incident. So what is happening here? Here light is propagating in the z direction. Okay, and this type of unpolarized light is incident. What is going to happen? What will happen here? Bolo beta. So basically you can choose any of the component. This is theta, I think. Okay, theta amplitude will be A. So you can say for this component, for this component A cos theta, this component is going to pass. Okay, A cos theta is going to pass, and its A component A sin theta. A sin theta will be reflected back. Okay, A sin theta. This will be reflected back, and this is passed. Okay, so what intensity due to this? This will be the intensity on the other side. A square cos square theta, or you can say this is I naught cos square theta due to one component. So here so many components are there, and this theta is varying from 0 to 2 pi. 2 pi. So if you consider all the components, they will have different angles. Okay? They are going to have all possible angles from 0 to 2 pi. So what you are going to do, what will be the intensity on the other side? Intensity of the transmitted light on the other side, that will be I naught, and average value of cos square theta. Okay, what you have to do, you have to find out this average value of cos square theta. Okay, average value of cos square theta that is going to pass. If unpolarized light of intensity I naught is incident, then for one component you calculated it, it's due to one component it will be I cos square theta. But cos square theta is continuously varying. It is continuously changing. Okay? Continuously changing it. So all possible orientations electric vector is going to have. So for one time period, if you take the average of this for theta from 0 to 2 pi, if you are taking one period of theta, then what it will be? This will be average value of cos square theta. You are aware that is 1 by 2. So this will be I naught into 1 by 2. 1 by 2. So average value of cos theta for one cycle of theta, that is 1/2. So intensity on the other side, that will be I naught by 2. So from here we are saying that if this is a polarizer, okay, this is a polarizer and unpolarized light is incident on it. This is unpolarized light whose intensity is I naught. When it passes through it, okay, then it will be converted into plane polarized light. Its electric vector will be parallel to the path axis of the polarizer. And what will be the intensity of this? Its intensity will be I naught by 2. This will be the intensity. So when unpolarized light is passed through a polarizer, intensity will become half. Okay? And when plane polarized light is passed through this, okay? When suppose you are having same polarizer, but this time plane polarized light is incident on it. Okay? This is plane polarized light. Then on the transmitted side, you will have plane polarized light, but its intensity I, it will be I naught cos square theta. So this Malus law, it is applicable only if plane polarized light is incident. So here I'm assuming its intensity is I naught. So this is all about this Malus law and polarizer. This type of questions may be there in exam. Many times they have asked this type of question. I have shared a sheet with you. Sheet of questions, please check.
Sir,
Yes, beta.
so we are passing a plane polarized light through a polarizer. The light is already polarized, and when we pass the polarized light through the polarizer, we get different intensity because due to the reason.
Because
It is
only a component of electric field is going to pass. Intensity change because here you are having plane polarized light. Its electric vector is there, but when you are passing it through a polarizer, only a component of the electric vector is going to pass. That's why intensity is going to change. Another advantage of this process is with the help of this, you can change the plane of vibration. Here, plane of vibration will be different. Here, for this plane of vibration may be different. So you can change the plane of vibration of a plane polarized light by passing through this through by passing it through a polarizer. So you can change the plane of vibration here. Is it clear?
okay.
So that's the advantage here. So it's not just to change the intensity. We are not using this one to change the intensity, but many times you need that plane of vibration. ठीक है ना? That should be changed. For plane polarized light, there is a plane of vibration in which all the electric vectors are confined. You want to change it. So you can do this with the help of a polarizer. Very simply. Now go to the questions. Question number 1 that I have shared with you. Example 1. Example 1. If linearly polarized light is sent through two polarizers, the first at 45 degree to the original axis of polarization. If a linearly polarized light is incident, so what they are saying you are having plane polarized light. So first this plane polarized light, ठीक है ना? It is passing through a polarizer. Here this is my polarizer P1. ठीक है? This is my polarizer P1. ठीक है? And after that there will be another polarizer P2. P2. So what they are saying, if a linearly polarized light is sent through a two polarizers, the first at 45 degree to the original axis of polarization and second at 90 degree to the original axis of the polarization. So what they are saying that that these electric vectors, they are making 45 degree angle, ठीक है ना, with the path axis of this polarizer. They have placed this polarizer in such a way that the axis of this path axis, it is making with the electric vectors 45 degree angle, and path axis of this is making an angle 90 degree with the original direction of the electric vectors. That is given here in this question. If you look at this question, this is given. ठीक है? Comma, what fraction of the original intensity passes through the last polarizer? So what will be the intensity here? I'm assuming intensity is I naught. So what will be the intensity of the light? So this will be plane polarized light. ठीक है? Plane polarized light. And its electric vector will be parallel to its path axis. ठीक है? Its path axis. So this is a plane polarized light itself. What will be the intensity here? That will be I1. This will be I naught cos square 45. Cos 45 is 1 by root 2. So what is I1? I1 is equal to I naught by 2. So now a plane polarized light, is falling on it on this polarizer P2. Now what is the direction of these electric vector? Direction of electric vector is parallel to the path axis. Parallel to the now electric vectors, they are having a direction that is parallel to the path axis of this P1. And you know that angle between these, the path axis of P1 and P2, that is 90 minus 45. So 45 degrees is the angle between the path axis of first polarizer and second polarizer. So when this light, plane polarized light, that is going to pass through it, it will emerge on this side. It will be plane polarized light. But what will be its intensity? That will be I2. And I2 will be equal to I1 cos square 90 minus 45. 90, because electric vectors are at angle 45 and its path axis is at 90 degree with the original direction of electric vector. So this will be 90 minus 45. This is I naught by 2. And this is cos square 45. So again 1 by 2. So this is I naught by 4. So I2 by I naught, that will be how much? This will be 1 by 4. This will be your answer. So 1 by 4 will be the answer. Option B. Option B is the correct answer here. So
So if
option, yes, beta.
the second polarizer is also in 45 degrees, we get the intensity as I naught by 2, right, sir?
Beta, your voice is, please speak loudly a little bit.
Okay. If the if the second polarizer is placed also in 45 degrees,
Yes,
then
beta.
we get the final intensity will be I naught by 2,
I naught by
right?
2. Correct. What is the
Yes.
question actually? Student is saying that if we made these two path axes, if we make the path axis of P1 and P2 parallel to each other, means this is at 45, this is at 45. In that case, electric vector of this, they will be at 45. Path axis of this will be at 45. So complete electric vector will pass. Complete electric vector will pass. And what you are going to have here in that case, that will be I naught by 2. But in this case, they are having an angle between their path axes that is 45 degree. Angle between two path axes is 45 degrees. So on this side, it will be I1 cos square 45. ठीक है? It is correct, beta.
So this question is mentioned as axis of polarization. So if it is given as axis of polarization, we should take it as the path axis angle.
So actually, when light is emerging from here, its electric vector is parallel to the path axis. So you can think electric vector parallel to the path axis in this way. In that case, it will be very easy to calculate the angle between two polarizers. ठीक है? Now, Go through the next question. Question number 2. Next question. An ideal polarizer is placed in between two crossed polarizers. So first is, what is the meaning of two cross polarizers? So before discussing this question, okay, what is the meaning of crossed polarizers? Okay. So first is crossed polarizers. Polarizers means you are having two polarizers. I'm assuming its path axis is at theta equal to 0. Okay, so this is polarizer 1 and I am assuming its path axis is at theta equal to 1. And if you place second polarizer here, this is P2, in such a way that its path axis is at 90 degree. Okay, so if angle between the path axis of two parallel polarizers is 90 degree, then they are known as cross polarizers. They are called as cross polarizers. Okay, so ये parallel नहीं बनी ना, they should be parallel actually. So theta equal to 90 degree and they are parallel polarizers. So what is going to happen here? Try to understand, if an unpolarized light, I'm saying unpolarized light of intensity I naught passes through it, then what you are going to have here, you will have plane polarized light. You will have plane polarized light here. Where will be its electric vector? Electric vector will be parallel to this angle 0. So what will be the angle between these electric vector and path axis of this? That will be 90 degrees. So cos 90 will be 0. So what you are going to have on this side? You will not have any light, and here intensity I naught, that will be 0 here. 0 here. So if two cross polarizers are there, unpolarized or even polarized light, if passing on the first one, you will get plane polarized light. But electric vector of this plane polarized light will be parallel to the path axis of P1. When they will fall on P2, these electric vectors will become perpendicular to the path axis of P2 and intensity is going to be 0 here. In that case, intensity will be 0 here.
Sir,
So, yes, beta, please.
sir, unpolarized light, when it will pass with theta equal to 0 degree, then in that transmitted light, the intensity will be I naught by 2, right?
Always, you can choose any angle here. You can choose 0, you can choose 20, 30, 50, 90, okay, any angle. If unpolarized light is passed through if unpolarized light is passed through a polarizer, intensity on the other side will always be I naught by 2. So it will be I naught by 2 always. You can choose any angle here. It doesn't matter. And this will be plane polarized light, and electric vector of this plane polarized light will be parallel to the path axis of this. Here, path axis is at theta equal to 0, so electric vector will be parallel to theta equal to 0 direction. If you make it 30 degree, then you will have intensity I naught by 2, but electric vector direction will be corresponding to theta equal to 30 degree. Okay, so direction of, if you are changing angle, intensity will remain same I naught by 2. Only only direction of electric vectors that will be changed for plane polarized light. So this is the meaning of crossed polarizers. Now come to this example. Example 2. So what they are saying, an ideal polarizer is placed between two cross polarizers in a coaxial geometry as shown. So what is here? You are having a polarizer here, P1. What they're calling it, they have not given the name. This is P1. Okay. and here there is another polarizer. They are on the same axis. This is P2 and they are crossed. So what I write here, theta equal to 0 here and theta equal to 90 degree here. Now another polarizer is placed in between them, and what you are doing, ठीक है ना, what they are doing, it is rotating. The middle polarizer is rotating at an angular speed of omega. So it is rotating. This one is rotating at an angular speed of omega. This P3 polarizer, this is rotating. ठीक है ना? It is rotating like this. So if you want to draw like this, you can. ठीक है? But simply you can draw like this P1, P2, and P3. P3. If unpolarized light of intensity I naught is incident on it, so here what you are having unpolarized light. Unpolarized light intensity is I naught. I naught. So what you are going to get here, you will have plane polarized light. You will have plane polarized light here. And its intensity will be I naught by 2. I naught by 2. Okay? This is the emergent intensity of the light would be, so at any instant t, okay, so I'm assuming at any time t, this angle between P1 and P3, angle between the path axis of P1 and P3 is theta. So what I am assuming here, let angle between the path axes of P1 and P3 is theta. And how much this theta will be? Theta will be omega t. Is theta equal to omega t at an arbitrary time t? At an arbitrary time t, at any time t, you can say. So what will be here at time t? I'm writing intensity here. So here also this will be plane polarized light. Here this will be plane polarized light. I'm saying this is I1. I1 is here. So I1 I'm writing here, I1 is I naught by 2. And here intensity I'm saying is I. So I2. So what will be I2? I2 will be I1. And this will be cos square theta. So this will be I naught by 2 and cos square theta. So at the instant when angle between P1 and P3, okay, so what I'm saying, that angle between P1 and P3, so in between these two, how much is the angle? Theta. So what will be at that instant, what will be the angle between the path axis of this and this? That will be 90 minus theta. So when this light is incident on it, then angle between these electric vectors and the path axis of this, that angle will be 90 minus theta. So on this side also you will have plane polarized light. You will have plane polarized light again. What will be the intensity of this? That will be I3. So I3 will be how much? I3 will be, this will be I2 cos square 90 minus theta. Cos square 90 minus theta sin square theta. So I naught by 2 cos square theta is here. And this is sin square theta. Sin square theta. So what you do if you multiply this by 4 here and 4 here? So if I make it I naught by 8, then this will be 2 cos theta sin theta whole square. So this will be sin square 2 theta. So this will be I3. Okay, if you look at the options, this type of option you are not observing. Okay, na? This type of option is not there. So I want to convert this sin square theta into, I can convert it into cos. So what I do, I divide the I divide this by 2, so this will become 16, and this will become 2 sine square theta. 2 sine square theta will be 1 minus cos of 2 theta, so this will be 2 into 2, this will be 4 theta. Now theta is how much? Theta is omega t here. Substitute here. So what will be I3? I3 will be I naught by 16. And this will be 1 minus cos of 4 omega t. So this type of question may be there in the exam based on Malus law. Okay. So this will be better. So today I am going to stop here. In the next class, I will discuss 1 or 2 more questions. But after that, I will start discussing mainly double refraction. Okay. So in the next class, I will start discussing double refraction. So you can save these slides.
Sir, can you show the third slide?
But just, yes. This is the third one, but
Sir, previous to it.
so I can show you all this slide. This is the first one you can save. This is the first one. Second. Third. Yes, beta.
We have seen that before. Malus law is applicable only for only when the incident light is a plane polarized light. Then the
Yes, Malus.
intensity of transmitted light will be I naught cos square theta.
Yes. So incident light should be plane polarized. And this cos square theta will be there when incident light is plane polarized. And theta will be the angle between the path axis and the electric vector of plane polarized light.
Okay.
So this is the third one. Fourth. This is fourth one. Fifth. Sixth. Seven. 8. 9. 10. 11. ठीक है ठीक है बेटा ओके
Sir,
बेटा थैंक यू वेरी मच यस बेटा
sir, it is given that theta equal to 0, theta equal to 90 in the polarizers. With
yes
respect to what the theta is determined,
you can
sir?
choose arbitrary direction as theta equal to 0 you choose one of the direction as theta equal to 0 ठीक है and corresponding to theta equal to 0 perpendicular to that will be 90 degree ठीक है so theta is not any particular direction you can choose any of the direction at theta equal to 0 here and perpendicular to that will be theta equal to 90 degree ठीक
Okay,
है
sir. Thank you, sir.
वेलकम बेटा
Thank you, sir.
वेलकम बेटा गुड नाइट बेटा